Okay, much like what Beth talked about, we're interested in trying to address this question. My title is a question. What are the sources and chemical forms of nutrients that go into the lagoon? And indeed, the answers to this question are pivotal to how we design and carry out the restoration of the lagoon, and in turn, how we spend the money we have to carry out this restoration. Sources are indeed important. So let me see if I can give you some idea of some of the things we've learned. So for today, I've got a few nuggets, sort of like a bunch of short stories. First of all, this is really tough work. And I'm going to introduce some things that are a bit complicated. My wife said they were okay, so I think I'll try. But next is, I'm unbelieved I'm even talking about this, but more than 90% of the material that makes up muck has nothing to do with sewage. And I was surprised that this has been going around the back alleys somewhat. Let me see if I can't clarify that. Then, our other finding is that the isotopic signature of nitrogen, and the nitrogen being released from muck, is the same as in benthic algae. The same nitrogen that's being blamed on sewage. I'll clarify that in much more detail. Then, next thing is, well-planned muck dredging should occur now because, and I'll tell you the answer in a little bit. And I want to thank the members of this committee, because one of the things you've done that's most valuable is you've been an open-minded group to realize we've got to sort of go down all these different avenues to solve the problem until we really figure out what the right one is. I don't know what the right one is, and no one else does. And so this is great, and I applaud you for being so open-minded. Okay, if you turn to your 2019 Save Our Indian River Lagoon project plan, you'll find some data in it. I threw it on a pie chart. And what it shows, as listed in there, is loading from different sources of nitrogen to the North Indian River Lagoon. And what it shows is that the release from muck, stormwater runoff, groundwater base flow in the atmosphere sort of take even amounts of what is contributed to the lagoon in nitrogen each year. It's about 680 tons in the North Indian River Lagoon. And each one of those might have an error of 10 or 15%. Maybe the stormwater is 24 plus or minus 10%. So we don't have them much better than that. But when I looked at this in the report, the first thing I thought, wait a minute, these aren't sources. These are transport pathways. Come with the muck flux, come with the atmosphere. We now need to look at sources. But when I looked a little bit further, down in the base flow here, there was a little caveat that said, septic, leaking sewer, reclaimed water. Those are sources. And I would add to those sources fertilizer. What happened to fertilizer? Why isn't it on the map anymore? Decomposing vegetation, biosolids, other organic waste, the things that Beth mentioned a few minutes ago. These are all specific sources, all coming by an avenue of base and groundwater flow, or for that matter, all of these come from stormwater runoff too. But we have to get back to the source, not just what's coming down the big creek. So that's what we're working on. And in our lab, we're working on muck flux, stormwater runoff, and groundwater. No one's working on the atmosphere. Okay. Just to give phosphorus its fair due, I'm going to do more nitrogen than phosphorus today. Austin is a phosphorus expert. Next time he comes, he can talk about that. But the only difference here is that we have muck flux, stormwater, and base flow. There's very little phosphorus in rain because it's not volatile, unlike nitrogen oxides that get up in the rain and come down. So we don't have much phosphorus in rain. That's cool. And that's about 70 tons per year. We have direct estimates of the amount of nitrogen and phosphorus coming down the tributaries, coming out of the muck, and these numbers make some sense. I think we're doing okay. Again, within plus or minus 10%. Okay, I'd like to focus in on, and it's embarrassing I'm focusing on something you think that's all I do is muck. It isn't all I do. But I want to show you something about the sources of muck. Where does muck come from? So let's go over to the next slide. And I have shown this slide 312 times. This is the 313th time. And what is Indian River Lagoon muck? No one listens to me. It's greater than 90% water by volume. That's unbelievable. Just think of it. It's really fluid, isn't it? And so that's one of the first things. But if you take and dry it out, I've been drying it out for 30 years, and one of the first things you find is that 60% of it to 50% of it is silt and clay. Silt and clay aren't in sewage. Silt and clay come from a well-identified source. They're coming off our land. So it's erosion of soil on the mainland or wherever. It's also washout from sod. There's a few percent silt and clay in all St. Augustine lawn. And that has washed out. You ever watch fresh St. Augustine go in and it rains? It looks like the Mississippi River if that house is at the lagoon. It blows your mind. And so that is what is the dominant component of muck, is silt and clay. Silt and clay is not in sewage. Okay. Then if you take quartz and carbonated shell material, we want it all to be mostly that, and that's just natural, so we don't have to worry about that one. And then the hard one. The hard one is organic matter. And so we can start with sourcing in two broad areas. One is terrestrial, the things that come off the land. Vegetation, grass cuttings, sewage, septic releases, those are all broad terrestrial input. And then we can take things that are produced in the lagoon. So nutrients create seagrass, the seagrass decomposes, it makes muck. Algae comes in, it decomposes and settles in, it contributes the organic matter that's in muck. So 10 to 20% of the muck is this organic matter that comes from a variety of different sources. Which one's more important than the other? Hard to know, isn't it? Well, as a geochemist of many, many decades, we use a variety of relatively sophisticated chemical tools to identify sources. And my wife said I could show this because she got through it. So bear with me. She's a psychologist. So what are isotopes? So an isotope is an atom of the same element that has a different mass. So for carbon, there are two naturally occurring stable isotopes of carbon. Carbon-12, that's 98.9% of the carbon on Earth, and carbon-13, that's 1.1% of the carbon on Earth. It turns out that there are minor variations in these percentages depending on where that substance is, what chemical reactions it went under, and you can actually trace it based on the relative ratios of these two isotopes. It's incredibly neat material. So let's look at the organic matter content of muck sediments and see if we can do a broad identification of a source, a broad source. I'm just going to go simple this time, based on isotopes. So these are data for sediments from Turkey Creek, the Grand Canal, Rockledge, and Mims. I've just sort of spread them out here so you can see the different places more clearly. There are isotope values down the bottom here. And you can see they range from about minus 27 to minus 18. Well, many years ago, 30 years ago, I did some work on the Mississippi Delta where I showed that what you could do was go and collect the things that grow in the Mississippi Delta or in the lagoon, that grow in the lagoon, like seagrasses, algae, and find out what their isotopic ratio is. In the lagoon, it's about minus 18 to minus 20. Then you can go back into the Turkey Creek or wherever you want, collect all the stuff that's coming down Turkey Creek or all the grasses, and what is the isotopic ratio of that? Well, it's minus 26 to minus 28. So that's terrestrial material. So when you look at these sediments, there's very little that's pure terrestrial material, and there's very little bit that's pure lagoonal material. Most of it is a blend. And so when you go to all these other sites, they're a mixture of material that came off the land, organic matter, grass clippings, whatever, trees, or material that was produced in the lagoon, seagrasses and things like that. And so you have a start. And if you go in Turkey Creek or at the mouth of Turkey Creek, it's 70% terrestrial and 30% marine. If you go to Mosquito Lagoon, it's 90% to 100% marine. There's hardly any terrestrial up there. So you got to start to look at that. So as you move around the lagoon, this is a first cut. This is just, I'm not going to take too many cuts on this, but the first cut, it's one way of looking at sources. So we've done this all over the lagoon a long time ago. Okay. Now I need to throw in sewage. So one of the important things here is when you look at the sediments in the lagoon, sewage typically has a carbon isotope ratio of minus 24 to minus 28. Very little of the organic matter that's found in this muck actually has a clear sewage source. And that fits. And we just have to, so muck is just a little bit different. I think sewage is really important. I just want you to realize there are two different carts. You just have to realize they're different. They're both really important. I don't disagree with that at all. Okay, so muck contains little or no sewage carbon. Okay. I keep going. Yeah. Matt's not glazed over. We're all right. Actually, he took a class from me and learned all this.
Dr. Trefry, as one of the 4 or 5 people that watch this online, could you get closer to the mic, please?
Yes, ma'am. I'm a roamer. Okay. I can't believe you can't hear me, but that's okay. Thank you. I will try to do that. Okay. We also can use other isotopes. In fact, no good study does anything with just one thing. An ideal thing would have carbon isotopes, nitrogen isotopes, and some of the chemicals that Beth mentioned. You gotta have many, many different tools in your bag to try and prove things. So now I'm going to switch and look at nitrogen isotopes. And just for the record, 99.6% of the nitrogen on Earth is nitrogen 14, and only 0.4% is nitrogen 15. But the fractions change depending on where that material has been, what chemical reactions it's gone with. They're neat tracers. They're just really neat tracers. So I'm going to take this away, and all of a sudden I'm going to go into nitrogen isotopes. And these are the same sediments down here. Oh, so they all have a nitrogen isotope ratio somewhere between 3 and 6. Okay, so we've had a lot of input from Peter Burrell about measuring nitrogen isotopes in macroalgae. And so he published in his paper that sewage has a nitrogen isotope ratio between 7 and 10. And then he went on to show that that matches what's in drift algae, and therefore sewage is the source of nitrogen to drift algae. So let's look at that a little bit more closely. I'm going to add just one thing to it. There are no data that I know of for nitrogen isotopes in sewage from Brevard County. This is just a number out of the literature. If you look at the literature in more broad review, the range is huge. Is it tertiary treatment? Is it primary treatment? Is it just coming out of a septic system? There's huge ranges in the nitrogen and carbon isotopes based on where that sewage came from. So we have a tracer right there, a really powerful tracer. But we have no data for that from Brevard County. I recommend you consider giving Austin Fox, as I'm retiring, some money to go look and collect all the sewage and do nitrogen and carbon isotopes. All right, so what we've done is to raise the point that I raised to Peter several years ago. Wait a minute. I know that the nitrogen isotope ratio of the nitrogen that's coming out of muck is the same as what you're saying is sewage. So we went and collected samples. You all are aware, I think, that decomposing organic matter in muck by bacteria produces nitrogen in the form of ammonium that comes out into the overlying water. And that's what we're concerned about when we talk about the muck flux and the release of nitrogen from muck. Well, the isotopic ratio for this ammonium is +5 to +10. And we've done quite a few of them, and it's what's in the literature. It's nothing surprising or new. But what's interesting is if we go back now to this other chart and add our number on here, this is ammonium fluxing from muck that we have running between 6 and 10. Basically, it's the same ratio that you find in benthic algae. In fact, I would contend if you look at the ammonium nitrogen isotope data and the data for benthic algae, you'd say, man, I think that's a better fit with what's in the benthic algae than sewage. But they both are there. There's definitely both there. To prove it, we need to use 2 isotopes plus other components. So what was done is good, but not adequate enough. So at this point, we do not know the relative importance of the muck flux of nitrogen relative to the sewage flux of nitrogen for nitrogen, phosphorus, silicon. We have not a clue. No one knows. And so this is something we can work on. We can work on trying to use these different tracers to get a better handle on what is the important source. They're both important. There's no way they can't both be important. But maybe one is more important in Banana River Lagoon, where another one is more important over near Rockledge. And we can actually zero in on those kinds of things. Big picture. Okay, that's enough of isotopes. Oh, I guess there's one more thing here. Just reminding yourself now that these are transport pathways. We're trying to zero in on individual sources, of which there are many. And so it's a complex task. Okay, you have just completed my short course in nitrogen and carbon isotopes. When you download this picture, you can just write in your name, and I've signed it for you. And if you want the full version, I'd be happy to teach you. It'll blow your mind what's known. You know, what's known in the world about all this stuff is beyond comprehension. This level of knowledge is beyond anything you could ever dream. I'm playing at level 0.5 on the Game Boy. There's level 10 up there. I mean, it's just, we are such a knowledgeable society. We got to use this knowledge. Okay, any more you want me to stop? All right. Okay, I'm going to go on to chemical forms of nitrogen phosphorus. It's not going to take me any longer than what it just took me to do this. Okay. As a chemical oceanographer for 45 years, no one in my field ever measures total nitrogen and total phosphorus. What an absurd number. What we measure are all the different components that make it up and add it up, and that's the total nitrogen. But if you know the total nitrogen, it's like having a black box. You don't know what's in it. And so if you take what we've done here, sampled different creeks, St. Sebastian, Turkey Creek, Crane Creek, and O'Galley River between 2015 and 2017, and took all the data and divide it up with the different forms of nitrogen were coming down these creeks into the lagoon, you get the following. About 60% is dissolved organic nitrogen. It dominates. What's in it? Something as simple as amino acids, maybe waste like urea, or some really complex nitrogen compounds that make up this dissolved organic nitrogen. Note that nitrogen and nitrate and nitrite are only about 15%. Ammonium is only about 7%, and then basically slime on particles, also called particulate organic nitrogen, is about 21%. So this is what, and it's actually pretty uniform for these 4 different systems. Now, it turns out that this has importance to how this nitrogen is used and cycled in the lagoon. So we need to know this and everywhere. Let me give you an example. So, as you may well be aware, the brown tide gained its notoriety in the Laguna Madre in Texas. Some colleagues of mine did a study there when the brown tide was on its height. And what they looked at was, how does brown tide grow as a function of the form of nitrogen that it's being fed? And so here's ammonium, and it reports here that there's a cell division of 1 division per day. Basically, that means that in 1 day, the number of cells double if you're using ammonium. If you go down to nitrite, it takes a couple of days or more for the number of cells to double. Guess what? Oreoumbra lagunensis can't even use nitrate, does not have the biochemical ability to use nitrate. Well, isn't it nice to know all these things? Well, the funny thing here is that urea is something, it's a proxy for the different waste products that can come out of any of these organisms. It grows really well on urea, organic nitrogen. Okay, from my studies in the Banana River Lagoon during the last brown tide, we had huge rains in September and October 2017 that brought in huge amounts of ammonium, nitrate, and nitrite. Huge amounts that sat there and sat there. And then by January, they were all gone. Yet the bloom went on for 3 or 4 more months at really high levels. During that whole time, there was no ammonium, no nitrate, no nitrite. The organism was producing urea-like compounds and using them, just living in its own waste for 3 months as fast as it could. And it pees that stuff out pretty fast. And so it's just living on its own waste. There was none of the other chemicals there. Wow. Interesting. There are so many different ways I can take this in terms of thinking about managing the system and so forth. But that's an example of the power of knowing the different forms. If you're looking at total nitrogen, hard to see what's going on. Okay. I'm going to go on then to just add a couple more things on forms, because this is key. This is the one you saw for nitrogen in the tributaries. For phosphorus, there's just 3 forms we're looking at. Phosphate's about half of it. So we call this the bioactive form of phosphorus. The most bioactive forms of nitrogen are ammonium and N plus N. Phosphate's pretty abundant. There's plenty of, relative to the total phosphorus, a lot of it is bioreactive. And organic phosphorus and particulate phosphorus. Again, I find it much more comfortable to think about the things that make this up. And then within this one, there's a grab bag of hundreds of things. So it gets pretty complicated. All right, now I'm going to move into the lagoon, because I'm trying to make one little point here. In the lagoon, as we go from the creeks to the lagoons, you can see the amount of dissolved organic nitrogen goes up, and the amount of bioavailable N plus N, nitrate and nitrite, and ammonium goes down. Particulate nitrogen is about the same. For phosphorus, big notice a sharp decrease in phosphate. It's being removed by the organisms that are out there. And so, pretty big change. We can follow this temporally, spatially, all different ways. There are some really neat stories. Even during the brown tide, what happened in one place to these chemical forms was quite different than in another place. But the last one I want to show in these pies is this. The ammonium that's coming out of muck is 99% ammonium. The nitrogen coming out is 99% ammonium. A little bit of dissolved organic nitrogen. The phosphorus that's coming out of muck is 99% phosphate and a little bit of organic phosphorus. Sewage is about the same. Most of what comes out of sewage is very bioreactive. So let's focus on these bioreactive elements. Let's put isotope markers on them, and then we can sort of chase them around the lagoon a little bit. This is expensive, time-consuming, and we've got to use it in the right places. Maybe pick one place to work at. Banana River between south of 520 or somewhere that's really a mess. I think it might be a great place to work. I think one of the problems there is we got too many canals that are all oozing out stuff. Okay. 30 years ago, I was approached by the Florida Inland Navigation District and Ted Moorhead, who was working with Bill Nelson, and they wanted to dredge Crane Creek and Turkey Creek. And I said, that's stupid. You can't dredge now. Muck's still coming in. I see this in the newspaper recently. Well, I learned that I was wrong. I don't think it's stupid to dredge muck now. And let's see if I can make my case to you. And so I've shown this slide many times. Stop the runoff that forms muck. Now you know what it is. It's soil and all the other things. And you can do all sorts of things to try to stop it. We're doing some of them, and I applaud the county for doing that. There needs to be more done to try to stop this, mainly the silt and clay, and to some degree the vegetation. Well, I went and looked at Crane Creek and Turkey Creek that were going to be dredged back in the 90s. And what I noticed was really interesting to me from what I had done back in the 80s was the muck had filled in almost all of Crane Creek and it was oozing out into the lagoon. And the idea of dredging that and creating a sump near the mouth was, hey, that makes sense. And so it would lessen the chance that that muck would go out in the lagoon. So a lot of the reason these tributaries were dredged was to try to keep it from going out into the lagoon. It seemed like a good idea. Okay, roll ahead to present, where we've done a lot of dredging in the tributaries or creeks or whatever you want. What about out in the open lagoon? Should we do that or not do that? Well, first of all, it does remove the solid phase nitrogen phosphorus forever, or wherever you put it. It does decrease, done appropriately, the amount of nitrogen phosphorus coming out of the muck. It does decrease turbidity, and son of a gun, it's a better place to live. You take the muck away and you'll find things that want to live there. You don't want to hear this, and I don't believe I'm saying it. I wouldn't have said it 30 years ago. We're never going to stop the ingredients that make muck from coming in. Right now, there are at least 2 people throwing grass cuttings in the lagoon somewhere. I have never been in the lagoon a day where I didn't see that going on. The lack of education and knowledge of the people of Brevard County is overwhelming. They just throw stuff into the lagoon all the time. I don't see, and if we don't, there's still stuff washing down the canals all the time. There's dust coming in the air. Therefore, we're never going to get it all out, but we can do some very sophisticated, well-planned dredging that works now and does a lot of good things. And I'm hearing this thing about, let's wait on the muck. Well, sure, but let's only dredge the muck that really makes sense. And that's a task that a lot of us have worked on. So, I'm done. And identifying sources is really tough, but we need it. And we need to do it in a focused manner. I'm really into maybe picking an area or two and really working hard on that area. So another important thing is we believe, Austin and I, that we've reached a tipping point. And that if we were to stop sewage now, it wouldn't be enough. And the analogy that we use is the fish tank analogy. If you don't clean the bottom crap, all the crap that's in your gravel out, you're going to have a mess anyway. And so to some degree, somewhere along the line, we've got to get this crap out of the bottom where it is. We now, thanks mostly to Austin, have really good maps of muck. And we estimate that it occupies maybe less than 5% of the area of the lagoon. That's a surprise. There are a lot of false positives in the old data. But it's still more than 5 million cubic yards, and it's still fluxing out at least 25 to 40% of all the nitrogen phosphorus that comes into the lagoon. Well-planned dredging should occur. Some of it's occurring. To date, I don't know of any dredging that wasn't paid for by something other than your money from the sales tax. So all the money that came from the state did all of the other creeks and so forth. So you haven't done anything wrong yet. Oops. And finally then, I think that as we identify the sources, we've got to really do that. Then we can make better plans of what to do. And I really push on that. Then along the way, we can't lose sight of understanding and looking at habitats and species abundance. This isn't all chemistry, it isn't all muck, it isn't all sources. And then public outreach and education. I got Courtney to agree with me that, believe it or not, everyone in this room is passionate. But of the 600,000 people in Brevard County, I think there's at least 500,000 that don't really pay much attention. And so I think public outreach and education are really important, done by someone really, beautiful and handsome and charismatic. Not me, not an old man. But I do think that that's important. I'm sad to hear that that's being poo-pooed, and I hope that's an issue. I have lots of friends, lots of colleagues, have had lots of money. I left all my money to Austin, but I thank you. So we've been funded by the St. Johns River Water Management District, DEP, funded through Brevard County and the National Estuary Program. I've never had any money from the sales tax. Austin may get some if you decide, which I think you should, that some small fraction of this money should go to science, because you are making decisions without the right data. And what do you find? I can't make the decision. Thanks. I'm done.
I actually was going to ask Virginia, because my understanding is that we can't, via the resolution, spend money on research.
Right. The current plan does not fund research. It includes the research priorities that have been identified through several previous efforts. The exception to that is in the respond section, where we are trying to measure the performance of the projects that we are selecting. You know, if in the course of that, we happen to collect some other information that's useful to future decision-making, you know, some people would call that research, but in the plan, we're calling it performance measurements.
Dr. Trefry, so what would you estimate the cost of some research like that? And not only that, but how long would that take? Right now, we're in year 2, and obviously we do have decisions ahead of us, and there are going to be others that have decisions ahead of us. And if that was something we would do, how long until we would have some results? Would you come out of retirement to help it speed it up? That's the other question.
Retirement means I'm not getting paid. I guarantee you.
So we're all retired.
Yes, that's exactly right. Since I retired officially on January 4th, I probably would have worked harder and more hours than anyone at FIT, and trying to finish a lot of what I'm doing. So, yes. So how long? It depends. The funding agency puts the pin on it. You could do quite a bit of sourcing in 1 to 2 years. And the cost of isotope analyses has gotten cheaper and cheaper. You have to go and collect the samples. You have to preserve the samples. Now, I think you could start to do a really comprehensive job of getting sewage. We have to know the sewage signature. We don't know what the sewage is. It's really hard to believe. If we picked maybe from from south of 520 down to Pineda Causeway and Indian River Lagoon, sort of my old favorite place was on the other side in the Indian River Lagoon. I think for $250,000 in 1.5 to 2 years, you could have made a huge project on that area.
Yes, Todd.
So I just first want to start off with, we've had a lot of presentations, and I want to thank you because by far this has been the best presentation I've sat through. And I would encourage us to never call this research, because this is data collection that's validation of the of what's going on. Mm-hmm. You know, you can do it in context of research, but this is no different than us monitoring septic tanks of whether we've got nitrogen coming out of septic tanks. And the other thing is, it is by far the most pertinent presentation that I've seen in terms of affecting the dollars that we spend, which is exactly the discussion that came on the commission meeting the other night. So I would, even though I don't really vote, I would highly support us looking at this, because we got tens of millions of dollars that we're going to spend that clearly everyone wants to spend effectively, and making sure that we're going after the right things, or that if we're going to go after something that wouldn't be the highest dollar return, that we're doing it consciously and for other soft reasons that might exist as well. But that at least we're equipped to make all of those decisions. And I don't think it has to stop us or even slow us down, because the reality is we know that there's things that will have benefit. Will they be the best decision? Maybe not, but they're the best decision today with the information we have. But certainly we should equip ourselves to make better decisions 2 years from now, so that we've got as effective a use of our money as possible. So thank you, and I think we should seriously consider, as part of anything we come back to the commission with, funding this type of data analytics that support our decision making.
I just add 2 very brief comments. One is that we need to come into the the 20th century because if you go to Sweden or other places, they're using all these isotopes. They're way ahead of us. Brevard County is a little behind on the quality of science that's going into supporting the lagoon. I have been around the world for 40 years, the Arctic, all over the place. I've only been back doing this for 3 years. And I just see we are way behind the curve in getting the science needed to make the decisions. So I'm asked, what should you do? I don't know the best answer. That's why what you're doing is fine, reaching out in all directions. But you're right on, Vinny. We got to do something to know that it's paying off. And how do we tell it's working? That's really tough too. I'm struggling with these things, and I really think about this. No, that's it. That's good enough. Thank you.
Charles?
Yeah, hi, Dr. Trefry. Have you had a chance to speak one-on-one with any of the county commissioners about this?
Not in the present session. No, I haven't in the past, many times. Going way back into the 80s and 90s when they were real receptive. Back when the county commission bought all the land on the Barrier Islands so no one ever built there, times have changed.
Well,
So I have not. I have not been I'm laying low.
because
So-
it was mentioned at the meeting that the county commissioners were open, and I think, are the county commissioner representatives here? Okay, so, there's been a lot of people going through their offices, and it seems like they should hear some science has been, very well documented, peer-reviewed to help with the decisions that are being made.
Or what we don't know.
And what we don't know,
Or what we think we know that we don't know.
well, science is all about, using the best knowledge. And as scientists, we don't have the absolute truth, but we base our decisions on what we know. It's fluid. We can change those decisions as we get more data. But I haven't heard anything today that changes any of the conclusions we made and recommendations.
Brilliant. But then Charlie was one of my graduate students. When did you graduate? 1981?
1980.
1980. Oh, God, we're old, aren't we?
Yes, we are.
You've already retired.
Before there was Muck.
Yes. No,
Well,
no, that's true. That's true.
before
We
we
didn't
studied
really
Muck.
find muck until later in the 80s. That's true. That's true. Wow.
John?
Sorry.
Thank you. Whomever does the recording, guys, if we can take this presentation and package it and get it up on the website, just for all the folks that live around where I am, to recognize this is way more complex than a quick little blurb that they write on Facebook. Much of it way over my head, not Charlie's, obviously, but it makes sense. So thank you very much. As far as the allocation of funding, we can recommend anything we want. This may or may not be inclusive in the legislation, but all funding is done by the county commission. So if they chose to fund this, they can do it. Doesn't matter what we say. Okay? We can recommend it and they can choose not to do it. They're the only ones that have a budget and the authority to spend this tax money. So hopefully they will choose to fund some kind of science like this, irrelevant of what we think.
Yes.
Dr. Trefry, is this presentation or something like it going to be at this symposium on the 26th, where I know Commissioner Lober will be in attendance because he's emceeing the event, so maybe he'll listen.
So I'm in on all those. I'm in on all those emails, but I've never spoken up. So I think they think I'm talking, but obviously I don't have to. So that's I don't know.
We would like you
And Austin can do just as well as I can do.
or Austin, yes.
Yeah. So I'm a little concerned about how broad that session has gotten. And we don't want to go out there and have sewage versus muck. It's not, we're all on the same team. And I try to tell Peter, we're on the same team. And he just doesn't get it. But they're both important.
I was going to say that, and I think what you just said was perfect, but I think if we can't, as advocates for the whole picture, we need people like you to speak. And so sitting back is not an option for you. I'm going to be on the phone with you. So it's important that we all, I agree, wholeheartedly. We have in the plan, even the 2018 plan, the largest portions of funding are going to septic tank removal and muck dredging. And we continue that on into the 2019 plan. So I'm not real sure what's going on here. I have obviously my opinions, but I think you being at things like this is vital or Austin, one of the two, because we need that voice, that, you know, the long-term scientists that have been studying the lagoon for the last 25 years need to be at the table.
And what we really want to do, John Windsor made up a great list of questions that the public asks, and we should answer some of those. That's where this bit of sewage and muck, they're not the same thing. They're just not. And other questions come out, just weird questions. So,
The Facebook warriors can be the worst enemies, and that's what we're fighting right now, so.
so yes, so I will probably be there.
Thank you.
And we can get the straws out again and see who talks.
Okay.
Charles?
So it was said by several of the commissioners that they're not scientists, and that's fine. So we have scientists, and since they're not scientists, it seems like it would be in the county's best interest to listen to those who do have the background to make the right decisions. You know, I mean, they make a lot of decisions, county commissioners and but they may not be accountants, and they may not be, you know, other areas that they have to delve into. But, you know, this is a unique area. Listening to the scientists is really important.
So one of the hard parts of being a scientist is to communicate. And so what I presented today on isotopes, I worked hard. My wife said the first time, "That's great, you can't do that." She didn't even improve the last one. But believe me, the concepts behind isotopes, you'd all be head on the table. I mean, even if I tried to make it, it's so complicated. It's just so complicated. So we got to be careful not to call it dumbing down. I didn't dumb anything down. I just tried to explain it. But and this may not be the only way to go doing all this sort of stuff. We got to be open-minded about it.
That was going to be my other question is, like, if we did want to move forward with, you know, further isotope analysis of, you know, sources and muck and that type of thing, how would we do that? I mean, what would be the process that staff would recommend us going through to provide, you know, additional funding for something like that? Do you know?
So I think the first thing is I can look at, there's the $1 million a year that's dedicated to respond money. And of course, we've already got things under contract for the groundwater monitoring wells, for monitoring our oyster reefs and our living shorelines and now Kilroy. So I can look at what is available and see, you know, if we could direct some of that to this kind of data collection and validation efforts. The other thing I wanted to say is, you know, this 2019 plan, we talked about this last month, but the initial plan was based on the best available data. And in this past year, we've done a lot of additional data collection and analysis, additional lines of evidence on, you know, what are the worst areas for septic that should be pursued for septic to sewer. And Trefry and Austin have, you know, collected loads of data on which of the muck deposits in the lagoon are fluxing, releasing the most nitrogen and phosphorus to the water column that are feeding these blooms. And so we've refined, we've reprioritized based on that new data. And so I think, you know, one important point, while there's still unanswered questions, we're not trying to pick which, we have a 10-year plan. We're not constructing all 10 years worth of projects right now. We're only constructing 1 year's worth of projects. And so if we construct the most important, the projects that appear to be the most important now, based on the data that we have now, there's a likelihood, a fairly good likelihood, that a couple years from now, when we have even more data, they may not have been the #1 project, but they were probably still in the top 10 years worth of projects. Right. And we've seen that with all of the work that we've done in the last year and a half, that while we found additional septic to sewer areas, that some of which were more important than some of our lowest priority ones in the first version of the plan, same thing with the muck, that the ones that we were moving forward on were still the ones that should have been in the money. So I don't want to leave anybody with the impression that we should stop, time out, you know, until we collect more information, because we know enough to get started.
And I think what what you just said and what Dr. Trefry said, where, we need to acknowledge what we don't know. And but we do have good data telling us where to go. We don't have data that says any one strategy is the smoking gun strategy. We have no data that says that. And so what we have in our plan is designed based on the best available data we have that says this is where we should go. And that's where I think if we continue on that path and then also fund the scientists to collect the data that we don't know and create that, get that data collection, not research, but data collection, done, that would be a huge benefit to all of us. So I think, what you said about acknowledging what we don't know, we need to make sure that we don't project what we think we know as fact. So.
And I would add one pet thing to all of that. The talent pool of scientists that are necessary to address some of these things don't all live in Brevard County. They don't all live in Florida. Some live in Texas. Some live in Sweden. I think we've got to bring in the best people. I'm a trace element and radionuclide chemist. I spent the last 4 years coming up to speed on all the nutrients and outfitting my whole lab just to do this. But we got to get, in every field, we got to bring in the best people. They don't have to be from here.
Yeah.
And some of the best work that's been done at Oriunga was done by people from Stony Brook and other places, not people from here. So that's what we got to get open to, too. Not we don't have to fund our own people.
Just on coordinates real quick, we don't have the information, or at least I don't have the information that I'd like to have in the lagoon. But with all the other NEPs and all the other bodies of water that have had the exact same thing happen, we can see what they've done. And we actually asked them to look at our plan and to comment on our plan and tell us what we're doing wrong. And they seem to reflect, if I'm remembering correctly, that the multifaceted approach is the way to go. So I agree we don't have enough information.
Right.
But I think comparatively, all the other NEPs have looked at it and said, you're on the right path. But sorry, John, go ahead.
So Virginia, you're preaching to the choir. This whole room and all four people on television is the choir, and we understand. And in 2017, we sat here with building an airplane while we were trying to fly it, was what we said. We thought we knew some stuff. We did know some things. We made the best recommendations that we could. And in 2018, and we looked at 40 and 50 projects brought in from various municipalities, and we evaluated them based on cost and used our nitrogen yardstick. And again, we did the best we could. And we got more information from the monitoring wells, from the research that you have done, sir, from other sources, from feedback from around the country. And again, we're doing our best to come up with a plan to present to this county to move this forward. And I think everybody's done a really good job. The fact that some people don't listen, who happen to have the purse strings, is another issue that we will address later.
So I think at this point, maybe I would make a motion that the asking staff to, I guess, research into how we would write up the data analytics that would allow us to know more about the efficiency at which we're spending money removing nitrogen.
Let the county do it.
Isotope, like,
Yeah,
that type
isotope.
of research that would look at sources and continue the work that's been done, I think.
Instead of staff doing this, why don't we let a county commissioner or two come up with this? Because they're the ones that seem to want to know more than we do at this point. And if we recommend it, it doesn't matter. Let them do it. If they want to change it, let them come forward and fund this gentleman.
I can understand the frustration right now, but I think, we still got to do our jobs, and I think, I would like breathe and just let the staff come back with a proposal of how we could participate in or the Lagoon Fund could participate in funding better research and let them figure out how to do that.
I just want to echo that because regardless of what pushback has occurred or not, I think it's absolutely imperative that we continue to take an active role to push this in the place that we think is the best spot. And no matter what the level of frustration or no matter what the conversation, I don't think it would ever behoove us to say, sorry, not on our plate. That's just not the right place to go. And we need to continue to own this and drive it forward and to take strong stances on where we think we ought to go. And at the end, I've got some things I want to say when we get to our own time. But, I'm definitely a firm believer of that. Look, whether we like where we're at today based upon the conversations that happened last week, look at the conversation we're having now, and it has prompted us to a whole level of detail to prove out what we're doing. That's not a bad thing.
I agree.
Is there a motion still on the floor? Because I'll second it so we can have a discussion.
Vinnie, would you repeat your motion?
My motion would be to ask staff to come back with some verbiage that would use lagoon trust funds for additional data analytics, looking at the specific isotopes to allow us to make sure we're spending our money, or the trust money, as efficiently as possible, or the county spending the trust money as efficiently as possible.
And I'll second that.
All right, so it's been moved and seconded that Virginia goes back and looks at ways that we might be able to utilize trust fund money, and the amount of trust fund money that might be available, that would be part of that as well, in order to be able to do some of this research on isotopes. All right? Any further discussion?
Let's call it data collection.
Yes.
Yeah,
Yes.
I think that's really important, not to call it isotopes.
Data collection, sorry. Hearing none, all those in favor signify by saying aye.
Aye.
Opposed? Motion carries.